All right, we're going to be getting started in about 1 or 2 minutes. If you have any specific questions that you want me to go over, just post those into chat. I already have three of the problems from the original worksheet, not the one that's due tomorrow, but the one that I assigned on, I guess it would have been Thursday last week. So I'll be going over those. It's a lot of kind of the same type of stuff. So, but if you have any additional questions that you want me to go over, just post them in chat, and I'll be ready in 1 second. All right, I'm ready to get started. So the three problems from the original worksheet, let me bring it up for you. All right, this worksheet, okay, the one that says 7-7, okay. So I'm going to go over your three problems from this. You guys already had access to the answer key for this. So you might already know this, but these were requests from from the comments that I got. So we'll start there. And then if you have any questions about the one that's going to be due tomorrow, just post those into chat and I'll do those as well. Okay. So to start off, here's the concept. Okay. We talked about already. Okay. Let's make sure my mouse is working. All right. So we already talked about problems where if I had something like this, right? If I had a square root, okay, and then on the other side, like I don't know, had a 7, okay, that if I wanted to get rid of this square root, that I can just square the square root, and that means that I also have to square the other side, right? And then that gets rid of it, right? And I get an answer, right? So we talked about this already. Okay, that was a couple of days ago. Okay, and then just to kind of make this a little bit more complicated, we said if there happens to be something like I don't know, like a -2 sitting out front, right? That before we can actually solve this, I'm sorry, before we can actually square this, we have to divide away or get rid of anything that's on the outside. So in this case, I would have to divide away the -2, right? Make that go away, and then I can square both sides. Okay, so what I'm trying to make the connection to now is if I give you a problem that looks like this, okay, that is the same as if I did x to the 1/2 power, right? Square root and 1/2 as an exponent mean the same thing, okay? So the idea was that if in a problem with a square root that I squared both sides and that canceled out the square root, that I should be able to do the same thing down here because it means the same thing. So for this problem, I'm just going to put parentheses around this, okay? And if I square it, okay, and I square the other side, that it should do the same thing. And it does, okay? So let me just kind of show you an exponent rule problem. If I had a problem like x to the third squared, okay, that's really the same as x to the sixth, right? We said we multiply these together. Well, if I do the same thing with the 2 and the 1/2, 2 times a half is just 1, and x to the 1 is really just x, right? I don't need to put the to the 1, right? I can just say that's x, okay? And then because I put the squared on the left, I'd have to put the square on the right, and that would be 49 as well, okay? So squaring a square root and squaring a 1/2 do the same thing. It just makes them go away, okay? So for this problem number 5, and for all of them in this whole section, okay, our job is going to be to get the variable alone, okay, or whatever contains the variable alone, and then I can get rid of that 1/2 by using a 2, or I can get rid of a 1/3 by using a 3, etc. Okay, so I'm going to start off by getting rid of this +6 by doing -6, okay, and on the other side I'll do -6 as well, okay, and that will cancel, okay, and I'm going to be left with the c to the 1/2, okay, and then 9 minus 6 is just 3, okay. So that's my start, okay? And now I'm in the situation where the variable with the exponent is alone, and so that means that I'm going to square, right? And that, again, that 1/2 times 2 is just c to the first, okay? And that just means I need to square on the other side, and that's going to make it a 9, okay? Same idea with extraneous solutions here, but if I check a 9, 9 to the 1/2 is just the square root of 9, so that's 3. 3 plus 6 does give me 9, right? So that is a good answer, okay? So is there any questions about just the concept of this? And if somebody could if anybody's in chat, just let me know that you're getting the audio and everything okay. I want to make sure that I'm not talking to nobody or nobody can understand me, okay? So just let me know in chat that everything's okay if anybody's there, okay? I know I have 6 or 7 people on already, okay? All right, so that's my first problem, okay? Any questions, just post them into chat. Okay, here's problem 16, which is a little bit more involved. Actually, I'll say a lot of bit more involved. Okay, this one's definitely more intense than the previous one. Okay, so the same idea with this one. I'm going to say, and if I pull out my highlighter, okay, this whole expression is what's being raised to the 1/4 power. Okay, so if you notice, I did not highlight the plus 12. That is not a part of this expression. Thank you, Maddie. Okay, so I'm going to start off by getting rid of this plus 12 by doing minus 12. Okay, and then I'm going to do the same thing on the other side, right? So if I'm going to do plus 12 on one side, I'm going to do plus 12 on the other. Okay? I'm sorry, minus 12 on the other. Okay. All right, and then this will go away. Okay, 7 minus 12 is negative 5. Okay, and so I'm going to get that 7v minus 2 raised to the 1/4 power, okay, is equal to negative 5. Okay, so the thing that contained the v in it is now by itself. There's nothing else on the outside of this parentheses, and that means that I can get rid of the 1/4 by raising it to the 4th power, okay? Because 4 times 1/4 just cancels. That's 1, okay? So that'll leave me with 7v minus 2, okay? And that's going to equal whatever's on the other side raised to the 4th power as well, okay? So I got to do a little calculator here. I believe it's 600. Actually, I know it's 625. I don't even need my calculator. It's 25 times 25, which is 625, okay? Now I'm going to keep going and solve this. 7v equals 627. Okay, v equals, let's see if we can do this math. 7 goes into 62, 8 times? 8. All right, and then that would leave me with, I believe, 6 left over. All right, it's going to be some kind of decimal, but here's the thing. Okay, this problem, I'm going to actually just leave it as the fraction, because I think it comes out to be a decimal. Okay, this one's going to end up being v equals some fraction 627 over 7. Okay, I don't actually care because this answer is extraneous. Okay, here's how I know it's extraneous. Let me go back to this original step right here. Right, when I got the radical alone and I was ready to raise this to the 4th power, if you notice, I have something being 4th rooted, and on the other side I have a negative. Okay, so here's a rule for you. I'm going to actually type it out because I think it's an important one. Okay, we're going to say any even root, okay, cannot have a negative answer. Okay? So just like how square roots are not allowed to have a negative result, we always just assume it's positive. That's actually true of every single even root that exists. So because we are 4th rooting when we raise to the 1/4 power, the answer cannot be negative. So I knew right here at this step where it says 7v minus 2 to the 1/4, where I'm doing the 4th root of this expression, that it's going to be impossible for that to output a negative 5. Okay, so I kind of went through this process just to show you like what you would go through, but at this step right here, I can just say I'm not going to get a solution for this. There is no answer. Problem over. Okay, be careful though. Notice I'm saying right here, I'm going to bold it and underline it for you. Okay, it has to be an even root. If this was to the 1/3, then the answer would be okay. There's no issue with getting a negative answer for odd roots like cube rooting and all that. Okay, so careful when you're doing those problems. This one is going to be no solution. Okay, so let's add that to our problem. Okay, we're going to say this is, with my pen, okay, no solution. Okay, this whatever it was going to be, okay, isn't going to give me a negative anything back when I plug it in, so it's definitely not a correct answer. Okay, so is there any questions about number 16? Because this one I think is a really good example of having to get the radical alone. It's not a square root, so we actually had to raise to the 4th power. Okay, and the answer happens to be extraneous. So this is a really good example of a lot of the weird things that might happen for these problems. Okay, So that one's up. I can pop back to it. I'm going to move on to the next one. Okay, but if you have a question, let me know. Okay, notice problem number 18. This was another one on that worksheet. Okay, this one is a cube root because it's raised to the 1/3 power. But I'm going to do the same thing. Okay, so I'm going to get this expression. Okay, oh, not my crayon. I don't want to use the crayon tool. Okay, get this expression, which is the thing that contains our variable u that we're solving for. Okay, I'm going to get it alone. That means that this plus 2's got to go. I'm going to get rid of this for the people that's going to bother. Okay, so I'm going to say minus 2, and on the other side, also a minus 2. Okay. 6u minus 5 being raised to the 1/3 power. Okay. This will cancel, so I'm not going to write that anymore. And on the other side, it says negative 3 minus 2, which is negative 5. Okay, so here's where you have to be careful. I'm going to go back to the previous one. I want to refer to it again. It says any even root cannot have a negative answer. Like 1/4, right? Raising something or fourth rooting something cannot be negative. Okay. On this one is a cube root. It is an odd power. Okay. It's entirely okay for me to get negative answers for odd powers. And if you're not sure about why, let me just explain it. If I do something twice, let's say I took like negative 2 times negative 2, my answer is going to be even, right? If I do 4 of them, okay, here's 3 and here's 4, okay, I'm going to get an answer, in this case 4 times 4, which is 16, also positive, right? So if you notice that there are 2 2's, my answer's even, there are 4 2's, my answer's even. And really what I care about is that these two negatives cancel each other out, and I get a positive answer. For this one, negative and negative cancel. This negative and negative cancel, right? And so I end up with a positive answer. But if I had 3 of them, right, negative 2, negative 2, negative 2, okay, these two are going to make a positive, but then I have this extra negative, right? So my answer here does come out to be negative 8, okay? So we have an issue when there's an odd number of things being multiplied together. There'll always be this extra leftover negative, right? And that's going to make the answer negative. So that's why when we have an odd root, like 1/3, it's going to potentially have a negative answer in it, right? So that's kind of the idea with that, okay? So for this problem, we're going to solve just like we normally would, okay? We are going to, now that we have the plus 2 by itself, we are going to raise it to the 3rd power. Let me get my, there you go, okay? I'm going to take this whole thing, and to get rid of the 1/3, I'm going to raise it to the 3rd. I'm also going to take negative 5, and I'm going to raise it to the 3rd, okay? So again, 1/3 and 3 cancel, and I'm just left with the 6u minus 5, okay? And on the right-hand side, it says negative 5, negative 5, negative 5. Well, that's going to be 5 times 5 times 5, which is 125. And again, we saw that if I had a negative and a negative and a negative, that these two will become a positive, okay? But then a positive and a negative will make my final answer a negative, so I should make this negative, okay? And now I can keep solving. I'm going to add the 5 over, okay? And that's going to make 6u equal to negative 120, okay? And then I'm going to plug in u, I'm going to divide by 6, and u is going to be equal to negative 20, okay? And again, it's okay that I'm going to plug in this negative 20, I'm going to cube root a negative, and I will get a negative answer back, right? So that's good to go, okay? Not extraneous. Hey, I am allowed to keep that one. So again, just be careful about your odds versus your evens. Okay. So is there any questions about the 2 other problems that were on this worksheet we did not go over? Let's see, we went over 5, right? Here's 5. We did not go over 6, and we did not go over 17. So if you want to see either of those, just let me know. I can do those for you and explain as I go, okay? And if you want to go over anything that's like something on the assigned homework, which is problems 1, 2, 3, 8, and 16, okay, we can go over something like those. Okay, but I believe they are fairly similar to what we just did. Let's just check. Oh, there's actually some small difference because these ones do have some 4/3 in them and 3/2 and other exponents that are not just 1 over something. So if you want to go over anything like that, just let me know. Okay, I'll give it a minute and make sure my daughter is still asleep. Oh, by the way, let me see if I can find it. Here she is. Today is her birthday. She turned 1 today, right? We were supposed to have a party on Saturday, but obviously that didn't happen. So we're going to be live streaming her smashing a cake later on. Okay, so we're doing the quarantine birthday party for her so everyone can see her. She's currently napping, I hope, because my wife is also asleep. So I'm on daddy duty in addition to teacher duty today. Okay. All right, so is there any questions about any of the other problems on the homework worksheet, which I think there should be on something like number 2 or number 3, right? Things like that. Oops, sorry about that. Okay. Yes. Okay. So that's what. Again, so here's the thing with this. It looks a lot more complicated, but it's actually not. So here's what I'm going to do. I'm going to make up one, and I'll just make up my own problem. It'll probably won't work out, but that's okay. Okay. So we're going to say, let's do something like. Actually, you know what? I'll just do number 2. So let me snip number 2. Okay. I'll do one of them for you, so then you can do the rest. Okay. So here's problem number 2, and I'm doing this because you guys are attending the live stream, so you get the advantage of knowing how to do it. All right, so here's problem number 2. So the idea with this is exactly the same. The only weird part about this one is how we get rid of the 4/3. Okay, we have to get rid of everything that's not connected to this variable. Okay, and here's where things are going to get a little weird, and I'm going to go back. Here's the only thing that I'm keeping. Okay, notice I did not highlight the 3. Okay. Take a look at this one right here. Everything's in parentheses, which means this is all being raised to the 1/3 power, right? This one, I don't have a parentheses around this, so the only thing that's being raised to the 4/3 power is the variable x, right? The 3 is not, okay? So I have to be careful with that, which means I need to get rid of this +5, and I need to get rid of this 3, okay? So just like we solved a regular problem, if this just said like 3x + 5 and this variable wasn't here, I would first subtract 5, then I would divide by 3, and then x would be alone. We're going to do the same thing. Okay, so I'm going to start off by saying -5 on both sides. Okay, and so that leaves me with 3x to the 4/3. Okay, terrible 3 equals 48. Okay, and then I'm going to divide away the 3. Right, so I'm going to divide by 3 and divide by 3. So x to the 4/3 is equal to, looks like 16. Okay. Now here's the fun step. This is where we get rid of the 4/3. Okay. I'm just going to come over here for a second. When we said something like 1/3, right, we multiplied it by 3. And the reason we did that was because 1/3 and 3 cancel each other out and they leave a 1 behind, right? 3/3, right, is equal to 1. Okay. And that's what we're trying to do. We're trying to make this an exponent of 1, right? So if I have something like 4/3, if you notice, these just happen to be reciprocals of each other. If I flip over 1/3, I get 3/1. Okay, so that's the way I'm going to get rid of the 4/3. If I don't want there to be a 4/3 there anymore, I'm going to raise it to the reciprocal power, which is 3/4. Okay, and that's going to be 12/12. Okay, which happens to also be 1. Okay, so that's what I want to do over here. If I want this exponent of 4/3 to go away, okay, I'm going to say raise this to the 3/4, okay, which means I also need to take the 16 and raise that to the 3/4, okay. 4/3 and 3/4 we just said makes 12/12. That's a 1, right? So this is just x to the 1, which I won't write. And now we have to do 16 to the 3/4, okay? So let me remind you about that because it's been a couple days, okay? The denominator means 4th root. So I'm going to say this is the 4th root of 16, okay? And then I can raise that answer to the 3rd power, okay? And again, I'll just show you that breakdown. 16 to the 1/4 to the 3rd, right? That's 3/4. That's the 3/4, okay? So if I take the 4th root of 16, that is 2 times 2 times 2 times 2, right? So this is 2 to the 3rd, which makes 8, okay? So I'm going to say that the answer here is 8, okay? And again, no issues because we were doing we're doing 4th rooting, so we'd have to be careful. But the answer was positive, so we didn't have any issues with that anyway. This is a good answer. We're good to go, okay? So is there any questions about that? Because that's I think, fairly intense problem because you're dealing with a numerator that's not 1. Okay, let me see what the other problems look like. You also had to do 1, 2, 3, 8, and 16. So 1 should be fairly reasonable because it's like one we just went over. 2 we went over. 3 is very similar to 2. And then what I see, 6 is very similar to 1 we went over. And then 18, fairly similar to what we just went over, except instead of having to do this +5, it's just the number that's attached that you have to divide away. But everything else I think is good to go. Okay. So is there any other questions or topics that you want to go over that are on either of the worksheets or something that's in the past? And while you're thinking about that, just to give you a heads up about what's going to happen this week, we have one more topic in Radicals that we have to talk about, which is how to graph them. Right, so we'll start that. I think I gave you the assignment today on the. So I guess I'll assign that to you tonight for tomorrow. We'll spend a couple days on that, and then at the end of the week, I'm not going to give you any new information. I'm just going to give you like what would be the review for a quiz, but I'm not planning on giving an actual quiz or test or anything on this. We haven't received any information yet that we should be doing anything like that. So we're just going to stick with learning for the sake of learning instead of having to worry about your grade. Just keep doing what you're doing and handing stuff in, and we're just learning for the sake of learning without having the stress of a grade. So we'll wrap up Radicals by the end of this week, and then next week we'll start something new, which will give us a little variety anyway. Okay. So I'm gonna hit mute. I haven't seen any additional questions come in. If you have any, I will keep the stream going for about another 20 minutes or so. Otherwise, try out those problems, and hopefully it helped out a little bit and makes some more sense. Okay, I'm gonna go check on my daughter because I think she's starting to stir. Have a good day if you're heading out.